All right, well, we have folks joining in now. Hello, hello, everyone. Thank you for joining us today. It's lovely to see you all in your little video screens. Hi, everyone. Good to see you. Thanks for joining us this morning. Welcome to our first of a series of workshops on AdaCAD called Getting Started with AdaCAD. One of the things we like to do, well, this is actually our first workshop, so you'll have to bear with us a little bit. But in our talk series, we really like to have people just drop a message in the chat on Zoom saying where they're from and just a hello to the group. So since we're all online, it can be a little, a little lonely. So it's nice to see you chatting in the chat and just say hello. So go ahead and open your chat. Hi, Teresa. Hi, UK. Hi, Bine. Portland. Nice. Is it gloomy in Portland? It's a little gloomy in Boulder today, which is unusual. Hi, Sam. Great. Hi, LD. We know who you are. Cool. Oh, this is amazing. Thank you so much. Well, we had a little bit of technical difficulties behind the scenes. So Deanna, who's one of our co-hosts today, is going to be driving the slides while I talk. I also wanted to give a quick reminder that we are recording. So we're hoping to record these calls and store them on our YouTube channel so people can tune in and watch the workshops later. Just wanted to let you all know that. So if you don't want your video to be recorded, you might just want to go ahead and turn your video off if that's available to you. So, okay. The workshop is actually going to be available afterwards. Deanna, can you go to the next slide? Oh, well, okay, I'll go back. Eda's going to drop a link in the chat that says where these workshop recordings are going to live. They're going to live on our documentation website. If you did register for the workshop, you should have gotten an email on Monday with a PDF. This PDF isn't required. You can still participate fully in the workshop without it, but it's just a helpful thing to have on paper. It includes some quick overviews of the interface, but also it has the curriculum for the 3 activities that are going to be part of this series. So if you downloaded it and you have it available, great. If you don't, that's fine. Eda is going to drop another link in the chat to where you can find the PDF of this document. Can you give me a quick thumbs up if you actually did get the email with the document in it? Awesome. Thank you so much. Okay, good to know. Deanna, next slide. All right, this is actually, had my slide order wrong. This is where we're going to be storing the workshops afterwards, the recordings. So you can actually reference them again, or people who couldn't make it today can watch. Next slide. All of these workshops and outreach activities have been part of a sponsored project by the National Science Foundation under a program called Pathways to Enable Open Source Ecosystems. So thank you to the National Science Foundation. We hope the funding continues, but we'll see how that goes. Next slide. Okay, and we are presenting this as the Unstable Design Lab. So we're a research lab at the University of Colorado Boulder. We are the developers of AdaCAD. AdaCAD emerged out of a research project for us. I'm a computer scientist and an artist, a 6-year weaver. I was new to weaving when I started this job. And for me, AdaCAD became a way that I could approach drafting as a form of coding and a little bit more algorithmically forward. And over time, we've been developing out and in community with weavers to see what it can offer to the community. It might not be for everyone, but we're hoping that we can show it to you today and see how you like it or how it might work. The three of us from the lab that are in this call today are myself, Laura Devendorf. I'm the director of the Unstable Design Lab, and I'm going to have our other two co-hosts introduce themselves. Let's start with Deanna. Could you just quickly say hello?
Everyone, my name is Deanna. I am a PhD student here in the Unstable Design Lab. I work on AdaCAD to think about what are some new interaction types that we can explore using this very creative and experimental tool. And today I am here leading the slide deck, but also as you get working in AdaCAD, if you have any questions, I'll be in the chat, but also can jump into a breakout room if you need a little bit more one-on-one help with the interface. So nice to meet you all and looking forward to today's workshop.
Yeah.
Hi everyone, my name is Etta Sandri. I'm a weaver, fiber artist, and now also a PhD student and researcher in the Unstable Design Lab. I first started working with the lab with Laura and with AdaCAD as an experimental weaver in residence in the lab a few years ago now. And yeah, I'm excited to support the outreach of this and the ability for weavers to connect and continue to share knowledge about different processes and techniques. So today I'll be kind of dropping links and reminders about our different activities in the chat. I'll also be fielding questions. So I'll be monitoring the chat for any questions and things that you guys have as we go along.
Thanks, Etta. Can you go to the next slide, Deanna? All right, so you might already know this, but AdaCAD is an experimental workspace that applies parametric design to the domain of weave drafting. So what we hope it does is support algorithmic and playful approaches to developing woven structures in cloth, and it can be used for both shaft and jacquard looms, or just, tapestry looms if you want to follow it by hand with a kind of draft. Next slide. So one of the kind of analogies we like to make about AdaCAD and what parametric design means in this context considers the case of weaving with imagery. So this is a picture of Countess Ada Lovelace, who the software is named after. And you can see we've done color separation and mapped different shaded satins into the image regions. So next slide, Deanna. So you might be familiar using Bhakti Zeek and Alice Schlein's The Woven Pixel for this process, where you think about your cloth as a kind of canvas that you're filling in. And AdaCAD's parametric approach works almost in reverse. So what you actually do is you start from the structures and build up. And you do this by creating a data flow. And the data flow basically does math on weave structures and combines them in different ways. So next slide. AdaCAD runs online. It runs at adacad.org. And again, in just a few minutes, we'll go through this step by step and get you started making your first data flow. Also wanted to point you to the documentation that's available at docs.adacad.org. That got a big update recently, and so you can find a lot of support materials, extra resources, descriptions of the software on that website as well. Next slide. All right, so today we're really going to be focusing on the interface and effectively navigating it, including both the workspace where you make data flows and the draft editor, which follows a more traditional point paper style drafting. And the goal is that you're going to create and manipulate your first data flow after today's workshop. The schedule is going to walk us through, if you did print out the PDF, you'll see that there's 3 different activities. We're going to be doing activity 1 today, and we've broken it down into 4 different parts. So loading AdaCAD and opening examples, understanding the data flow and parameters, modifying a data flow, and then visualizing the draft. We're going to leave about 15 minutes in the end for open questions and answers for anything that comes up. As questions come up for you, you are more than welcome to add them in the chat. Go to the next slide, Deanna. Yeah, so You're welcome to add your questions to the chat. If you see a question in the chat that you are resonating with and that you also have, just give it a thumbs up. Etta and Deanna are going to be monitoring the chat and trying to answer your questions in there as they come up. If required and you need some one-on-one help, Deanna and Etta might ask you to meet in our emergency room, which is a breakout room we have in Zoom, though that's sort of a worst case scenario. After the workshop, we have a channel set up on a service called Discord. Discord is really a great place for community groups to join together, support each other. And we've created an AdaCAD channel on Discord. There is a Q&A section in that channel. So if you have questions after the workshop, you're more than welcome to post them there. And we're looking at that daily. Because we're doing this like Zoom weaving workshop on one screen, it's a little bit confusing. We sort of imagined your setup is having your own version of AdaCAD open, which we'll walk you through, with the Zoom window and the chat in the corner, and this printed to follow along. What we're going to do during the workshop is we're going to show you a series of steps, and you are just going to be able to watch that. You don't actually have to follow along at the same time. We're going to ask you just to watch our screen, and then we're going to take a break, and we're going to give you a task to perform on your own, and then we're going to see if you're able to do it. So you don't have to face the pressure of listening to us and following along. It's going to be split up into two parts. So we'll tell you when it's your turn to do something. Sound good? And again, this is our first workshop in the series, so thank you for being patient with us. Next slide, Deanna. All right, so let's go ahead and get started. Are you ready? Woo. Okay, so Deanna, you can go ahead and close the slide presentation. I'm going to show you, oh, Etta, that's very cute. Thank you. I am going to go ahead and share my screen here. I already have AdaCAD open, but let's pretend I didn't. Okay, so to get to AdaCAD and to open it, I'm going to open my browser window. It works best if you're using the Chrome browser. You can use AdaCAD on a tablet, but it might have more bugs than if you're using it on a computer. So open an internet browser window and type in the address adacad.org, and that's going to open up AdaCAD for you. Because we've just launched this new version, we have this little welcome message. You don't have to do anything there, you can just close it. So what you're seeing here is the AdaCAD interface. I'm going to actually walk you through at this point these features up here on the top bar. The top bar is this top blue bar, and we think of this as kind of the control center for the software. This is where you're going to be loading and saving files, where you're going to be controlling your settings, and so on. So there's three main things here I want to focus on today. The first is maybe the most non-intuitive and helpful feature, which is switching the modes of AdaCAD. So if you're in Workspace mode, you're going to be able to create a data flow. If you're in draft mode, you're going to be able to draft like you're using point paper. And we'll go a little bit more depth in this mode later. But I want you to know that at any time as you're using the software, you can switch between those modes. So if you make a draft here on the Workspace, you can go ahead and flip over to draft mode and do further edits there. Okay, the next important feature, and this is maybe especially important because this is homemade software. We three are the developers, and you know, we really like offering it to the community, but it has its bugs. We're not a company, we're sort of doing this as a research project, so we try to make it as stable as possible, but bugs are going to come up. One of those bugs is that every once in a while, maybe the software is going to freeze. And if you haven't downloaded your Workspace, you're going to lose that work. So one of the ways we try to prevent this is by having a login feature. So if I click login, I can create an account just with my Google account, or I can log into an existing account. And what it's going to do is it's going to save my files for me. So now that I'm logged in, if at any point I want to go see a past project I worked on, I can go to Manage Save Files. And of course, since I'm working on this a lot, I have a lot of saved files here. So this is just one simple way by logging in that you can kind of save your work in case anything bad happens. And we don't use this login information for anything else. And you're the only person who has access to your files that are stored on the AdaCAD server. You can also download your files locally if you need. More on that later. Okay, so we have the workspace switcher, the login. The next step is one that we're going to have you follow in just a second. It is up here, this little light bulb here. I can even zoom in. Oops, let's see if I can zoom in on my interface. Oh, no, I can't. This light bulb here, if you can see where my cursor is, if I click this, this gives me examples and templates. And the template we're going to be working from today is called Making Your First Workspace. So again, I'm just going to click on the light bulb and I'm going to click on Open for Making Your First Workspace. Okay, this is the part where you get to do this. So Eda's going to drop the instructions in the chat of what you're supposed to do. We want you to go over to your browser window, open this AdaCAD example, and give us a thumbs up in the chat when you're done, okay? And I'll just show you what that thumbs up looks like. Perfect, great, Eric. Cool. I'm not seeing everyone's screen, so if you could do the thumbs up in the chat or yes, like Ruth is doing, that is great. Cool, this just gives us a sense of following along. If you're having a problem or a question's coming up, you're also welcome to go ahead and do that in the chat. All right. There's something poetic about writing the word thumbs up. Okay. Eda, I'm going to wait for you to tell me when I should move on because I tend to be a little jumpy and you tend to be calmer. So why don't you just give me a signal when you think it's good for me to move on?
I'm seeing a lot of thumbs up and confirmations in the chat. So I think let's move on. And if anyone is getting a little stuck at this step, feel free to ask a question in the chat or to message me or Deanna directly, and we'll help you out.
Okay. So we are going to move on then to step 2 of our activity. Step 2 is a tour of the workspace. And then we're going to ask you to make some changes to this workspace after we're done. So one of the most helpful features in this workspace are the ability to move around. So if you click the workspace, oh, somehow I'm annotating, my apologies. Oh, Zoom's trying to be too helpful. Okay, so if I click the interface and I use my mouse wheel, I can scroll up and down, left and right. If I want to zoom in, I can use these control features down here at the bottom left of the screen and zoom into my workspace. I can use the zoom bar to get really close or zoom out. And one helpful feature that has emerged and actually came from another user suggestion is this zoom to fit feature. So if any point I get lost in my interface, I can click this button on the far left and it'll take my entire workspace and fit it in the screen. Okay, so those are the zoom features. I'm going to go ahead and zoom into the very top of our data flow. You'll see here that we are looking at the twill operation. Every one of these boxes on the workflow in the data flow is called an operation. And what an operation does is it takes the rules of a twill and it generates a draft from them. So the twill operation basically wants you to tell it how many warps are raised, how many are lowered, if it's an S or Z twill, if it's warp or weft facing. And if I change those features, it's going to change the twill that results. So I can change it to a Z. Maybe I want it to be the other facing. So every operation has a different set of these inputs that you can change. And these inputs are called parameters. And that's what makes this parametric design. So what's really nice about parametric design is I have my twill generator here. And let's say I want to change that twill in some way. Here I can take the output of my twill and put it into the input of another operation. In this case, this makes symmetric operation. And it's going to take the output of this operation, feed it into the input of this operation, modify it, and return you a new draft. So in make symmetric, I can change what kind of symmetry, what corner it's going to be rotated around. So one kind of fun thing here that I actually really enjoy is if you zoom out and you change the parameters, it changes all the way down the workflow. So instead of sort of designing your draft where every individual pixel is individually defined, you're creating rules and relationships for the structures that you're making. Okay, so let me make sure I got to all the things I needed to do. The one other thing I wanted to explain here is that these yellow things here are called notes. I think of them as sticky notes. And in these notes, I just write comments or instructions that are helpful for me, you know, why I chose this structure, what material I'm going to use, you know, and on and on. So, okay, the last note I want to point out is that every operation has different kinds of inputs. So you'll see that a twill takes two numbers, which correspond to the number of warps raised and warps lowered. And it also takes a direction and a facing direction. These numbers you can click on and either use your arrow keys to increase and decrease them. You can erase it and type a new, there we go, a 93 twill. That's a wild one. You can just write in a number and hit enter. For these drop-down lists where you have a defined set of options, you just hit the drop-down list and change your selection. There's a few other kinds of parameters in AdaCAD, but we're just going to start with these today. So this brings us to our next assignment for you, the audience. Eda, again, is going to drop the assignment in the chat. You are going to give it a thumbs up when you are done. And your job in this assignment, finding it on my list, we want you to make a 3-3 twill. Okay, so go ahead, basically, change the parameters, see what happens, and see if you can go ahead and change that to a 3-3 twill. Okay, and thumbs up when you're done. Eda, I will give you the job again of telling me when we're okay to go. And if you're done early, there's nothing to stop you from just moving some of those other parameters and seeing what happens. I personally believe the best way to learn is just to play and to try to break things. And so go ahead and break it all you want. You can hit reload and reopen the example if you make something catastrophic happen.
I'm seeing a lot of thumbs up and yeses in the chat. And then I'm seeing a question from Mimi about how do you disconnect the pink connecting line? Maybe you could show us that as people are
Yeah,
continuing with their twill.
that's great. So when I click the output, you'll see that I get this little eager connecting line that has nowhere to go because everything already has an input. If I want to get rid of it, I just have to click any blank spot on the workspace. Yeah, in the future, these are actually really great features and like little things that I might miss. So in the future, if you find something like that and you're like, oh God, I really wish I could just push this button and make that pink thing go away, you could also hit this question mark and report it as a bug or a feature request. And that'll go in my little development log. So that's one of the nice things about this being open source software is that you can actually make requests for what you want it to be. Okay. Yeah, I'm seeing when the faces change, warps raised and wefts raised number remain the same. Yes, so this is sort of a figment of me being a computer scientist first and a weaver second. So for me, when I created these operations, I consulted a lot of weaving texts and tried to sort of figure out what the algorithm for each structure or manipulation is. When I think of facing, I intuitively think of changing all the white cells to black and all the black cells to white. So it'll keep the numbers the same, but it'll change their order essentially. So it might be a little bit different than how the structures are taught in weaving, but it's a feature function of being very true to the math so that it's unambiguous. So in most cases, when I'm designing AdaCAD, I am doing things so they're as non-ambiguous as possible and that they don't make any assumptions about what somebody wants to do. So it's going to always take the instructions very literally. Sometimes that's good, sometimes it might be a learning curve. Okay. All right, so we have a lot of thumbs up. These questions are great. We're doing great on time, and so we'll definitely have a Q&A at the end if more questions come up. I'm happy to talk about them then. Let's go ahead and move to our step 3. We're going to now change this data flow. So we're going to add and remove nodes, nodes operations from this data flow. So as you can see, I have all these different operations here, and they are all different colors. The color of the operation corresponds to these regions over in the left sidebar. Operations that generate weave structures are called structure operations. Orange. transformation to take a weave structure in and manipulate it in some way. Cloth arranges structures in different orders, and color effects allows you to specify different colors in your draft. So in this starter workspace, we basically have one of each category chained together. What I want you to do now, and what I'm going to have you do when we have our follow along section, is to add a new operation and transformation and see what happens. So I have a few different operations here for structures. Some of these structures are known weave structures like satin. Others are more mathematically defined like random. So, I can create structures by giving it a ratio of lifted warps to lowered warps. That one's a little bit wild, so I'm going to delete it. If you want to delete one of your operations, like you add it, you play around with it, you don't like it, you just double click the operation and scroll down to delete. Okay? Now, I added my satin here, and I'm going to go ahead and put it into the stretch operation. The stretch operation is going to take every warp and weft and duplicate it. So I use this a lot when my density on the loom is really high and I want multiple groups of warps to operate as one. Sometimes I'll stretch my structures. So I can stretch them along the warp, or I can stretch them along the weft. What's kind of interesting here is that I could add these two together as a separate workflow, or I could swap it out, right? So I've created my satin, then I've stretched it, and now let's say instead of tiling this twill structure, I want to tile this stretched satin. What I would do here is scroll over and hit the X on this little connection between the symmetric operation and the tile operation. Dink. Then I'm going to click the outlet of the stretch operation so it turns pink. And then I'm going to click the inlet of the draft operation. And now you'll see that it's going to tile this structure instead of that structure. So our next activity for you here, one other feature I wanted to preface is that, for instance, sometimes you can kind of interlace these drafts in different ways. So maybe I want to remove this connection. I can have this draft going to more than one place, right? So I can see what happens when I make it symmetric or when I stretch it or not. So in this activity, we want you to help play with the connections. I've just told you here what these operations do. If you find that you're using the software and you don't really know the purpose of the operation, again, you can double click it. If you hit help, it'll open the description and the documentation for that in our documentation. And it just opens that in a new tab. So now I can go back to AdaCAD and it's still there. Okay, so perfect. Etta just dropped a link to our documentation of all the operations if you just want to explore. If you're already feeling pretty confident and you want to see all the weird and wonderful operations, you can flip the Show Advanced Operations tab, and there's a lot more funky, weird stuff in there. But as we're learning, just go ahead and we can keep it with the simple operations. All right, so your next task is to modify the data flow. I want you to add a new structure and a new transformation and integrate that into your data flow. Okay, so we're going to go ahead and turn it over to you. Give us a thumbs up when you feel satisfied. Okay, so we have one question just about how to make that connector appear. The connector appears anytime you click an outlet. So an outlet is this little down arrow at the bottom of the draft. Oops. Oh, look at this. And now seems like, oh, there's mine. Maybe if you're zoomed in far, it disappears. I don't know. But you'll see that that outlet also turns pink. Even if the line doesn't appear, sometimes you can click an outlet and then click an inlet and it'll still work. All right, for the sake of time, I might move on to the last step. We can come back in the Q&A if you got lost or you want to restart again. Again, if you do get lost or you're like, I don't know what happened, you can go back to the examples here and just reload it. And then you'll see it start from scratch, all fresh and new. Okay, so let's go ahead and talk about one of the final features that, again, parametric design is good for some things. For other things, it makes it a little complicated. So one of those learning curves is in applying colors. So as we talk about applying colors in this task, I want to point your attention to one other option. So anytime I click a draft in my data flow, you'll see that it shows up over here on the right side of the screen and what I've been calling the viewer. So the viewer also has a zoom function, so I can scale it in and out here. And if you want more or less space for the viewer, you can take this slider and move it bigger or just get rid of it if it's not helpful for you. What the viewer is doing is it's taking whatever draft you've selected and it's giving you multiple ways of seeing multiple representations of the resulting cloth from that. So by default, it's showing you a setting that I call, I'll go here, pattern. So pattern is basically going to apply color that you've specified to the warps and wefts, and it's going to show you an approximation of what the resulting cloth will look like. If I want to change that view, I can go to view options here, and I can pick a different option. So one is structure. This is just going to show me without colors how the floats are interlacing with one another. If I want to see the draft a little bit larger than I see it in the workspace, you can open it in the draft view here. There's one other feature that I've been working a lot in the background. It's still experimental and prone to bugs, but it's called simulation. And this gives you a 3D rendering of what your cloth might look like. So for me, this has been partially a teaching tool to show how interlacements scale, but over the next year, I get to go on a sabbatical and I plan to work a lot more on this simulation feature and hopefully get it to be a lot more robust in terms of how the yarns pack and also separating into multiple layers. So more on that soon. I would, for the most part, stay in color pattern. That is the safe zone. So we've talked now about the different visualization modes. Other things that you can do in the viewer that are helpful is you can pin this draft to the viewer. So by default, anytime I click on a draft or anytime I change a parameter, it's going to show the draft that I'm changing in the viewer. But sometimes I want to see what happens to this draft when I change this parameter up here. In order to do that, I'm going to hit pin. So I have now pinned this draft to the viewer. And if I go all the way up the chain and I start changing my parameters, I can start seeing how it affects the resulting cloth. And in this way, you can really play a little bit more visually with what the resulting cloth is gonna look like. So this is the viewer. One of the final things that I wanted to show you, and the last step of our workshop today, is how to actually manipulate which colors we're using. So most of the operations we've used so far have take a draft, just one draft as input, and spit out one draft as output. This operation, set materials and systems here, this one takes a draft as input, and it takes a second input called systems and materials. What it's going to do is it's going to take the drawdown from this draft, and it's going to take whatever material sequence is shown in this draft here and repeat it across the warps and the wefts. So since I've said it goes red, red, blue, blue, it's going to tile red, red, blue, blue across as many warps as it's needed. The simplest way to adjust these patterns are to click in those color squares. So if I click in those color squares, it's going to alternate the color by one, and it's going to cycle through the range of available colors. Okay. Maybe you want a larger repeat sequence. Maybe you want to draw on these a little bit more freehand. In that case, you would want to double click and say open an editor. Okay, let's zoom in here. Now I have opened my draft in the editor. I can pick from the colors here and redraw them. Maybe I want to do purple and yellow. If I go back to the workspace, you'll see that they're all purple and yellow now. Okay, I'm going to go back to the editor. Maybe I want to add more warp ends in this sequence. Yeah, I'm going to have it be repeat every 7. And I'm going to do some white alternating with purple on the weft and some yellow alternating with black on the warp. Again, I can go back to the workspace and I see the results on my draft. If you wanted to make one of these drafts from scratch, you could go ahead and just use the add draft feature. So this is going to add a blank draft of a certain size that you specify to the workspace, and it is doesn't have to be generated by an operation. So this is what we call a seed draft. So again, I can maybe put a different color sequence in here. I can delete this one, and I can add in my new color sequence to materials and systems, and I can see the result of that. So this brings us to our final activity. We want you to change the colors. So come up with a color scheme, either by changing the existing colors that are in there or making a new seed draft, and visualize it. See if you can come up with an interesting drawdown where you like the color patterns. I like this one because it's a little bit of an optical illusion. So we're going to give you just about 5 minutes to do this, and then we'll open it up to the Q&A. If it's not too distracting, I can answer some of the questions in chat, but I think I will actually answer those in the Q&A because I want to give people a moment to just focus on changing the colors, and then we'll come back. Okay? So your final task, change the colors on the final draft. Give us a thumbs up when you feel like you found something you like. So one experimental feature we can try, what I've noticed is in the chat in this version of Zoom, you can add images. So if you want to take a screenshot of the draft that you made and drop it in the chat, I'd love to see it. Yay! So pretty. Oh, it's really fun to see these. Cool. Thank you, Sue. Oh, Teresa, look at this. Did you use the layer function? Double waffle. Oh my God, what's better than one waffle, but two? That's really beautiful. I love it. I love a draft, I'm not gonna lie. I enjoy these colors too. All right, so we're getting towards the end of our session. I wanted to point out two final things. You are more than welcome to keep dropping your drafts in the chat. We love to see them. Two things I wanted to call your attention to from here. One is this little color palette in the top left. I gave AdaCAD some default colors. If you actually want to go in and change those colors or add your own colors, you can do so here. So again, I'll show you where I got to that again. I just hit the little color palette in the top bar. I can go in and adjust any one of those colors, or I could even go in and add my own color here at the bottom. When you add a color, it adds it to the list that it'll just cycle through if you click on that material button. We didn't get into warp and weft systems today. That's also something you can modify by clicking. That's a more advanced feature. We'll get to that later. The final feature is how to download your draft. Maybe you want to make it on something like a TC2 or a CompuDobby Loom. What you would do is select the draft that you want to download. So maybe I want to download this draft that's in the viewer. There's multiple ways to do it. The easiest one that I prefer is to, in the viewer, click this little download button. It's in the bottom right of the screen. And then I can select the format that I'm going to download it as. So it can be a bitmap if I want to maybe send it to a TC2. It can be an image. That's like if I just want to save a pretty picture. Or it can be a WIF file. So you could load it on maybe a CompuDobby Loom, or you could open it in another tool that supports WIFs like Fiberworks or WeavePoint. So these three features really focus on downloading your drafts. And you can do that for any draft in the workspace. by just clicking it and again, hitting download. It is going to download with whatever name you give it here. By default, every draft is called Drafty. So when you hit download, it's going to save wherever your computer saves downloads from the internet as drafty.wif or drafty.bitmap or drafty.jpg. So that's how you can get these out. If you want to save your whole workspace and you want to load the data flow again, you click this little download button that's directly under the workspace. So again, you can download your whole workspace and then later open it in AdaCAD if you'd like. One final thing you can do that I really enjoy is you can hit share. And if you share it, you can turn on sharing. It generates a link that you can send to somebody else, and then they can open the workspace on their computer. So you can imagine maybe you have like a chain letter of drafts where you start one, you give it to a friend, they change it, they send it back to you. It sounds like I'm going to have to start doing one of these. That is all I wanted to cover in our lesson today. Thank you so much for sticking with us. We're probably a little bit over time. I'm happy to stay for another 15 minutes to answer questions. But yeah, let's open it to the floor for some questions. And the best way is just to drop your question in the chat. Yeah, I feel like chain letters were something I grew up with, but I don't know if they exist anymore. Yeah, Bine, that's a great question and something that we have been thinking about a lot. So, especially with the simulation, it would be very cool if you could sort of identify the thickness of the yarn, maybe something to the effect of certain characteristics like how stiff or springy it is, and have that affect the simulation. It's not impossible. There's a simulation tool. There's different simulation approaches that can do that currently, maybe not specifically in the domain of drafting. But yeah, hopefully soon. And thank you, Sue. I basically made this because I really was bothered using Photoshop. I felt like I could code these so much faster than clicking all the pixels. So I think you're picking up on that. All right, Erica says, is there a way to start with a blank structure? Yes. So if I wanted to, let me zoom out here. Let's say I'm just going to start a new workspace. I could go to this home here and say new workspace, and it gives me a totally blank workspace. And then I can just say add draft. When you add a draft, you have to give it a size. So I'll give it 20 warps by 20 wefts. You can always change that later. And then it's going to add that draft to your workspace. There's different ways you can manipulate this draft. You could click on the screen and just assign the different values there. It's probably easier to move over into the draft editor. Let's see, open an editor. And I can modify the drawdown here. The reason that I'm modifying the drawdown and not a threading or a tie-up is because I'm in jacquard mode. If I changed my type of loom to a shaft and treadle loom, for instance, it would automatically generate me, a threading and a tie-up from my drawdown. I'll show you one final feature, although we'll cover this more in Workshop 3. You can alternate whether you want to generate your threading from the drawdown, or you can change the drafting style here and generate your drawdown from the threading. Give it something a little straighter and, draw on the tie-ups. Any other questions? Oh, thank you. Well, maybe I'm not seeing a bunch of urgent questions. We will still stay on the line for a little bit longer, but before I lose everyone, I did want to just call your attention to a final few events. So let's see. I'm going to go ahead and share this. Okay. So our goal after this workshop is that maybe you keep playing, you ask questions, or you can share via our Discord channel. You can find